All right,
Are we good?
we're starting your 6 minutes right now.
Yep, see your
Okay, just give me
thingy.
one sec. Sorry, just 1 second. I just got to get the right thing up. And all right, good to go.
All right, good to go.
Okay, fantastic. Thank you so much for joining me. Thank you for your time, Brian. Thank you for moderating and to my opponents for being here. And of course, thank you to my friend Ember for being part of my team. Now, Flat Earth on Trail. I only really have three things that I want to go through, and the Flat Earth side will have to provide answers for these three things. The first one is the Polaris and Crux, why that can be seen in the configuration it can be seen in. Polaris could be explained because it could be up here, but the Crux not so much, or the Southern Cross. Now, these two different models, it's easily explained why Crux is only visible from the Southern Hemisphere, but not from Asia. It just makes no sense on a flat Earth. Why can somebody over here in South America see it, but not somebody in Asia? It makes absolutely zero sense. So I'll be expecting an answer to how that actually works. The next part is circumpolar star trails. Why do they happen the way they do? So this is from the Northern Hemisphere. Whoops. This is from the Northern... sorry, I'm having trouble with my slides. This is from Northern Hemisphere. They actually go in a anti-clockwise direction in the Northern Hemisphere. And if my thing would actually work, I could start it. So they go in an anti-clockwise direction in the Northern Hemisphere. In the Southern Hemisphere, they actually go in the opposite way. They go clockwise. Now, this is a massive problem for the flat Earth, and I'll explain why in my next slide. Because at the equator, I want to focus on the equator here. What you should see is the center of these circumpolar star trails at the horizon, basically, with the stars going overhead. Now, this is how it works on a globe model. You can basically see counterclockwise Northern Hemisphere, and then when it goes to the Southern Hemisphere, we see them traveling clockwise. This is the problem. If you're in South America and you look south and the trails are going in a clockwise direction, that's fine. You can look north and see them going in a counterclockwise direction here. That's perfectly fine. Problem is that if you then move around with the same configuration to Asia on the equator, that is the wrong direction. That is the wrong direction. That is clockwise looking south and anti-clockwise looking north. So the flat Earth people will have to explain how that works and the configuration that allows that to work. The third thing I want to talk about is flight times. This is two flights, LAX to Tel Aviv in Israel, and this is Sydney to Johannesburg. They're both about the same time. They're both about the same distance. This is how it works on a globe Earth. Again, both about the same time, about the same distance. Fantastic. This is how it works on a flat Earth, or rather doesn't work. This is twice, or probably more than twice, the amount of distance traveled from Sydney to Johannesburg and LAX to Israel. And the flat earthers will have to explain how the planes can suddenly double their speed over the speed of sound to get from one place to another. That'll be interesting to find out. So those are my three questions. How can the Crux constellation be seen at the same time in Africa and south of Australia, both looking south in different directions according to their model? Why are the solar circumpolar stars at the horizon at the equator rotating in the wrong direction if looking south in different places on the flat Earth? Why does that happen? Why do flights deviate so far from a straight line? But also, why is it half the distance, according to the flat Earth map, takes the same time? They're going to have to answer that question. And that's the questions I have for them. Thank you.